Welcome to Gas Laws. We're going to take a look at all of the fun and fantastic things that gases do. And before we can understand any of that, we have to understand something called the kinetic molecular theory of gases. Okay, there are 5 postulates to the kinetic molecular theory. Okay, postulate number 1, gases consist of molecules whose separation is much larger than the size of the molecules. Okay, that means you might have a molecule over here and a molecule over here, but even though the molecule is really, really tiny, there's a lot of space in between them. Okay, so if we were all in the gym, okay, it would be like, you got like 15 people on the basketball court. Okay, the separation between those people is much larger than the actual person. Okay, same thing with gas particles. Okay, postulate number 2: particles in a gas move in straight line paths, however, in random directions. Okay, so all of the molecules that are in this room are not all going that direction at one time. Okay, they're all flying all about. However, their pathway is a random pathway. Okay, they'll fly in a certain direction until they bounce off of something, and then they'll bounce off into another random direction. Particles in a gas collide frequently with the sides of the container. Okay, so if I've got some gas in here, okay, obviously there's some liquid, but obviously there's some gas as well. Okay, the gas particles are colliding very, very frequently with the sides of the container. Okay, it says all of those collisions are elastic collisions. Okay, and an elastic collision just means that no energy is lost or gained as a result of the collision. It says particles in a gas do not attract or repel one another. What that means is that they do not have intermolecular force. And the last part of the kinetic molecular theory says that the average kinetic energy of all the gas particles in a sample is proportional to its temperature. Okay, and what that means is all of the particles in this room are moving at a certain speed. Okay, if you were to take the average kinetic energy of those gas particles, then that's going to be what the temperature is made of. Okay, so the faster that the particles are moving, or the more kinetic energy that there is, the higher the temperature is. All right, and vice versa. The colder it is, the slower the particles are moving. So this is the next important part of the video, dealing with the units that all of our gas stuff is measured in. Okay, number 1, we're going to be talking a lot about pressure in this unit. Okay, pressure can be measured in atmospheres, torr, kilopascals, millimeters of mercury, or psi. Okay, and more things besides that, but these are the ones that we're going to be talking about. Now, I do want to show you something. This, my friends, this is not an atom. Okay, that's not what it is. It is an atmosphere. So please say atmosphere when you're referring to ATMs. Okay. We're also going to be dealing a great deal with volume. Volume can be measured in liters, milliliters, cubic centimeters, cubic feet. Okay, those are the ones we're going to see in this class. But we can have any measure of volume for these problems. Okay. Now, here's a very important one that you will need to understand. T, temperature, is always, oh, and also the variable that you're going to see for pressure is P. The variable that you're going to see for volume is V. The variable that you're going to see for temperature is T. Okay. However, the temperature for all of these problems, guys, all of these problems has to be in Kelvin. Okay, it 100% has to be in Kelvin. Now, you're going to see that a lot of the problems are going to give you degrees Celsius, and then you'll have to convert to Kelvin. Okay, so if you remember, if you've got something that's 25 degrees Celsius, if you add the number 273 to it, it'll give you the Kelvin. Okay, so 25 plus 273 would be 298 Kelvin. And then if we're talking about amount of gas particles, amount is going to be represented with an N, and it's referring to the number of moles of gas particles. So here's some things that we need you to remember and understand. The temperature in all of these problems has to be in Kelvin, no doubt about it. Okay. Here are your conversion factors for pressure. Remember, this is on your green sheet, so you don't have to have this memorized, but you do need to know how to work with it. And lastly, let's see here, STP. STP tells us that we are dealing with 1 atmosphere and 0 degrees Celsius. So If a problem says, oh, we're at STP, you know the pressure already is 1 atmosphere. You know the temperature already is 0 degrees Celsius. Okay, those are some things that you'll see in this unit, and yeah, so get ready for awesomeness.